Hello, my name is Nili. I am a researcher at UPIDE, and I am very excited to share with you a transdisciplinary research we conducted last year in DV. I would like to highlight that our team was comprised specialists from a variety of fields, including education, psychology, statistics, electroencephalography, retinology, archaeology, among others. You can access the introductory article we publish in Edge Science by scanning the QR code or visiting the Edge Science magazine website, where we describe how we do the experiments and some reference. Now we share with you the full analysis of each task and the results. Okay, first of all, direct vision, also known as extraocular vision, refers to the phenomenon where visual experiences are generated from stimulus that do not directly fall on the eyes. While ancient references allude to existence of direct visions, it wasn't until the last century that scientific texts began to explore this topic in more detail, including experiments to understand it better. In Mexico, pre-Hispanic societies often associated such abilities with shamans and healers. However, from 1790s onward, we found evidence of Mexican scientists looking for a scientific answer to this ability. For instance, we found Guillermo Altamirano and Jacobo Greenberg, who have inspired the UPIDE team during this research. Both Jacobo and Guillermo describe how students who worked with extraocular vision became more intelligent. Some developed the ability to heal or read minds. That makes me wonder if it is possible that seeing without the eyes is the trigger or the result of a much more complex process that happens in our brain or in another part of our body or our consciousness. Take for an example, A. In these years that I have been working as a DV coach, I have seen a huge number of students who manifest feeling an improvement in aspects that affect their lives for the worse. Conditions such as autism, hyperactivity, anxiety, depression problems to socialize seem to disappear partially or completely after 3 or 4 sessions. In such a high percentage that it makes us think that perhaps it is not coincidence. Take, for example, A. She was a 5-year-old girl diagnosed with childhood depression that after 10 sessions was a happy girl who enjoys school again, as her mother says. Or Audrey. She was an 8-year-old diagnosed with autism that after 6 sessions she asked to work with his classmates, sit with them and eat with them, began to speak and communicate. This is F. He is a 7-year-old child with selective mutism. After 4 sessions, the mother calls me to show me this video. Crying at the phone, she said, "This is the first time Franz speaks at the school, and I want to share with you."
Y entonces le dijeron, ya cállate, le disparan en la panza y ella empieza a decirle a Concha, soy una dona.
¡Ah! ¡Bravo!
Y entonces le dijeron,
And she's Eunice. She is my favorite student. Despite being completely blind from birth, she developed such levels of perception that she stopped using her cane in school. She learned to move on her own, and she is able today to ride a bike and dance with a group of people without bumping into them. Watch her during an exercise after approximately 6 months of DV training. ¿Qué forma tiene y qué color tiene?
Es redonda.
Muy bien, perfecto. ¿Qué color?
Amarillo.
Amarillo. ¿Qué es? ¿Sabes lo que es?
Sí.
¿Qué es?
Una manzana.
By observing these and other similar cases, we found it interesting to try to understand how DV works in order to seek to give it an application that can be implemented in individuals and also perhaps in schools. This is how the idea for this research was born. Our experimental group was composed by 9 children between 7 and 10 years old. They were trained with the DV method, which is based on meditation, non-formal education techniques, self-progress of the children, and teamwork. After 6 sessions, they were ready to solve the skills that we designed for the research. Well, the control methods. To achieve a better control in the test, the children use a mask with a thick layer of foam that adapts to the kid's face anatomy, preventing possible holes under the nose. Throughout the experiments, we use 4 security cameras placed in strategic locations to record the test from different angles and an additional camera in the ceiling. Inspired by the experiments of other authors, we made a completely opaque box that would function as an extra barrier between the participant eyes and the target. To avoid using physical material that the children might recognize, we developed 2 mobile applications. One displayed random images while the other showed numbers from 0 to 9 in 4 direct colors: blue, red, yellow, and green. You can access to the apps by scanning the QR code. And we apply a series of psychological tests designed for children that evaluate stress level, coping, and how children internalize and externalize their problems. These tests were applied before and after the preparatory course in order to measure whether there was any change at the psychological level that was reflected in the results of the test. Unfortunately, when applying this test, we realized that it was not the right one for our specific group, so we recommend repeating the quiz with a test more suitable for the group we are working with. The experiment consists of a series of 5 tests, 3 experimental tasks that included DV box, matching cards, and Uno game, and 2 exploratories that were pupil dilation and EEG recording. This is the box task that involves placing a cell phone inside the DV box and using our app to randomly display 3 color numbers on its screen. The children were required to identify these numbers and colors solely by touch with their hands inside the box. For the matching card test, the child was shown 5 cards with different pictures and then given 5 identical cards which they needed to place over their corresponding pair. To explore how DV might manifest in a more playful setting with social interaction, the next task involved playing Uno game. In this game, the children had to choose a card from their hand that matched either to the number or color of the card on the table. We asked for the collaboration of our ethnologists to perform a pupillary dilation in 2 of our students in order to induce them to a clinical condition where it would be impossible to read letters of less than 8 millimeters at a distance of 30 centimeters. We dilate the pupils of 2 participants to ensure that regardless of their mask, they were in a clinical condition where it could be highly improbable for someone with normal vision to read 8 millimeters letter from a distance of 30 centimeters. Additionally, we connected 5 students to an 18-channel Easy Cadwell 3 device to monitor and change any change. We established a baseline before activation and measured the control time after doing activities such as drawing or describing an image. For the experiment, we used the video electroencephalogram method like this. Okay, the results. In the DV box task, the results were analyzed separately for color and number occurrence. We employed one-tailed binomial test for this analysis. For the color binomial test, the observed success rates suggest that participants could perceive the card color at a rate significantly higher than a chance, that is P equal to 0.021. In contrast, the number binomial test resulted in no significant deviation from the chance in predicting the card number. P was equal to 0.707. In the Uno game task, 9 children participate in this task, resulting in a total of 103 attempts. Out of these, 75 were successful, 18 were failures, and 10 were abstentions, which were excluded from the analysis. The binomial test result indicates that the success rate is significantly higher than the expected by chance. But even if we consider the abstention as failures, the success rates remain highly significantly. In the matching card test, each participant completes 5 exercises, providing a total of 45 samples. Of these, 29 were successful and 16 were failures. According to the one-tailed binomial test, the expected probability was 20%. The result exceeded this expected percentage, showing positive outcomes. The 2 girls were able to read 8 millimeter letters from a distance of 30 centimeters with dilated pupils. Therefore, we did not proceed with the blindfold task. Remember, that is would be highly improbable to read that size at that distance with pupil dilation. Electroencephalography. We performed a Fourier series decomposition in the EEG data. We calculated the ponderate average of the positive frequencies obtained. 3. Finally, we calculated the variance in the amplitude of the positive frequencies. With these variances, we realized a non-parametric comparative analysis considering a non-Gaussian distribution. Using Mann-Whitney U test, we compared all the control time frame versus the direct vision time frame. We obtained a significant difference of about It is important to remember this is an exploratory test, which gives us a lot of insights but needs to be taken carefully. Trying to learn more about the data, we perform a similar analysis comparing the experimental versus control conditions by EEG channels, which did not show significant difference. Similarly, compression between hemispheres did not reveal any significant difference. The conclusion, although we did not find significant difference when analyzing each task per student individually, by hemisphere or by EEG channel, there seemed to be significant difference between experimental and control times. This opens the door for future research, trying to look for direct vision psychological difference in the brain. The findings suggest that a promising potential for creating visual-like experience without using the retinas. However, the key question is not whether this is possible or not, but how it can improve the life quality. At TUPIDE, we are already developing new protocols to further explore this ability, its implication, and the potential benefits for the humanity. Thank you very much.